Alright, so we're looking at problem 1.22. As with any of these problems, my numbers will probably be slightly different to you than yours because of the random thing that Mastering Physics does. So it's telling us a unit of time 1 year is 365.25 days. And then it's asking us to tell how many seconds there are. In my case, I'm given 1.10 years. Now, for this case, because it's giving an exact value of days, which actually differs from the front of the book. The front of the book has 365.242 days per year. And this does make a little difference in the number of sig figs here. It shouldn't, but we're gonna take this out in the full stream of things. So we're gonna build our conversion factors. So I'm gonna start with my 1.10 year, and I need 365.25 days. Let me get my line straighter there. Per year. I'm building these equal signs. Well, there's 24 hours. I shouldn't say equal signs. I'm building these fractions out of equivalencies. 24 hours in a day. 1 day equals 24 hours. Well, we can turn that into a conversion factor. And 60 minutes in 1 hour. And 60 seconds in 1 minute. And so let's see, years cancel. I'll do this in another color to highlight it. Years cancel, the days cancel, the hours cancel, minutes canceled. So I'm left with 6 seconds, which is the unit I want. So I'll go back here to my wonderful calculator. And let's clear out what I had there before. So I just have to multiply these things across the top. 1.10 times 365.25 times 24 times 60 times 60 equals 34,713,360 seconds. Well, we're going to write this in scientific notation. We started with 3 sig figs, so we're going to keep 3.47. This doesn't round up, so it's 3.47. What are my decimal places? 1, 2, 3, 4, 5, 6, 7. So I'm keeping 7 decimal places. So 3.47 times 3.47 times 10 to the 7th seconds. And that's what we get in the book, or that's what we get in the answer here. And that gets us through part A on this. Now for part B, as I crinkle my pages here, it asks us how many nanoseconds there are in a year. Now, we're going to be playing with the power of 10 here. So we don't need to build a conversion chain. But what we know is nano, which is written as n, is 10 to the negative 9th. So for every 1 second, you can divide it into the 10 to the negative 9th parts. So we're dividing into 10 to the negative 9th parts. So for part B, we take our answer from part A. And notice the word choice I said. We're dividing each second into 10 to the negative 9th parts. Over 10 to the negative 9th nanoseconds. So 10 to the negative 9th seconds in 1 nanosecond. And so seconds per nanosecond, I'm going to put my ns up here. Those will cancel. And I have a base 10, so my rules of exponents say 3.47 times 10 to the 7 minus 9, 16. So watch your rules of exponents. They can save you some. You don't have to run to the calculator here. Your base 10s will give you what you need. And so I get 3.47 times 10 to the 16th nanoseconds. That's a lot of nanoseconds in a year. So that's part B. Let me label these A, B. Just so when I plot the images up there, we can keep it straight. Now for part C, my question then says, how many years are there in 1.8 seconds? So we're kind of reversing our conversion. So 1.80 seconds. Well, I want to turn this to years. So in 1 minute, I have 60 seconds. In 1 hour, I have 60 minutes. So notice I'm flipping the conversions I had before because we're running in the other direction. And the reverse of multiplication is divisions. Or you can think of when you're reversing your unit conversions, you're flipping the fraction. We're saying the same thing using different English words for it. But the math is we take the reciprocals of these. And so in 1 day, there is 24 hours. And in 1 year, 365.25 days. And so seconds cancel seconds, minutes, minutes, hours, hours, days, days. I'm left with years. So this is what I want to run through my calculator. A neat trick to remember with calculators is that your commutative properties and your associative properties, the fact that division is an inverse of multiplication, all these come together. So I can go 1.80, and I can think of these as successive divisions. So divided by 60, divided by 60 again, divided by 24, divided by 365.25 equals, and I have a lot of decimal places, but let's count over. 3 sig figs again, so I'm going to keep 3 significant figures, which is 570. The 3 doesn't round it up, so I'm keeping 570, and let's count my decimal places. 1, 2, 3, 4, 5, 6, 7, 8. So 5.70 times 10 to the negative 8th years. And so we can figure out how long 1.8 seconds is to a year. It's a very small fraction of a year, right? And this part of the scientific notation is showing us it's a smaller number. It gives us a sense of its size.